Hello there. In this video, we cover the dplyr package. So dplyr is a very commonly used package, meaning something you need to load into R. It's not part of base R. Um, so very commonly used to manipulate data frames, and it makes it very easy and intuitive, all sorts of data analysis. Now, how do we install such a package? Very simple. Uh, in your R session, in R Studio, you will use the command install.packages and then simply the name of the package. So in this case, dplyr with this spelling. Now, once you've done that, and you need to do that only once, because when you do that, the package is installed on your computer. Once you do that, to use a specific function from the package, you can use the following syntax. Now, frankly, I never use that, but if you want to use a specific function, you could use, well, in this case, dplyr dot 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 dot, and then the function with specific arguments, and this will work. I say I never use that because in reality, it's much more practical to load the entire package inside your R session, and then you can access all of the functions that come with the package. So, because in essence, a single package can contain lots and lots of functions that do different things. So in general, if you're interested to use dplyr, you want to use all of the functions inside dplyr. But again, if you use only one function just a few times, you could use the syntax. But what you would do almost always is load the entire package. And so again, careful, this is a different command. So library dplyr. And now just to repeat, this command installs the package. You need this only once, but this one library, you do need it every time. So every time you want to use dplyr in an R session, you will need the command library and then name of the package in quotation marks. Okay, so let's assume, so I recommend you to install it now. So you install it once. Might take, I don't know, some time, shouldn't be too long, maybe a few minutes at most. And after that, you need to load it with the library command, and then you can access all the functions inside the package dplyr. Now, there are 6 kind of main functions that we're going to cover here. There's a few more, but those really are the main ones that, again, are going to make our life as a data analyst easier. So those are filter. We can use it to select rows. Select, can use it to select columns. Arrange simply sorts rows by by the order of some variable. Mutate, very useful to create new variables, so creating new columns in our data set. Group by and summarize are usually used together, so you're going to group certain rows together and then summarize them in some way. All of that is a bit abstract. Frankly, here it's going to be much easier to explain those functions with examples, and hopefully as we go along, you'll see the usefulness of using dplyr. But first things first, we'll start with filter and select. So throughout, we're going to use the empty cars dataset. So here we just visualize the dataset using head. I'm just displaying the first 3 rows here. You see it's a dataset about different car models with some information like miles per gallon, cylinder, I suppose. This, I don't know what it is. That must be horsepower. This, I don't know what it is, weight, and so on. So let's first cover filter. So filter simply allows you to grab some rows based on whatever criteria you want. So for example here, filter empty cars. So that's the syntax. You need to name the data set. So here I'm telling R, okay, I want the data set empty cars, but now I want to filter for miles per gallon bigger than 25. And careful here, it's going to select all the rows such that the variable MPG is bigger than 25. So you see that's the result. The data set has been filtered such that we keep only rows where, careful here, it's MPG bigger than 25. You see there's apparently six cars that have MPG bigger than 25. Seems to have worked. And here, I'll give an example in a second, but you could have more than one criteria. So if you want to filter based on several criteria, it's possible. I'll give an example in a second. Now we have select. Now select will select columns. So entire columns rather than rows. So you use that to keep only the columns that you like from the data set. The syntax is the same, but careful, you start with the data set and then you name, followed by commas, all the columns that you want. So in this case, I'm going to select from my empty cars only the columns that have those names, MPG, sil, and weight. Now, just a small how you say mnemotic or mnemotechnic, a memory trick. Okay, I forget the correct word, but the memory trick. Filter as a R, so we select rows, right? Because rows has a R in it. Select as a C, and we're going to select columns, and columns as a C in it. Okay, that's my little trick to remember that filter gets me some rows, and select with a C gives me some columns. Mnemotic, I think, is the correct word, right? A mnemotic trick is like a memory trick. Mnemotic, I think that's the correct word. Anyway, so here you see I've selected all my data set for the correct well, columns that I wanted. And then, okay, this is my example. Of course, you can combine those two operations. And here, just to illustrate, careful here, you have a select and then a filter. So let's look at the inner one. I'm filtering, so I'm selecting certain rows. And here, this is what I said. You can have many criteria here, but careful, this is like an and, right? So I want MPG to be bigger than 25 and weight smaller or equal to 2. So you see, MPG, they're all still larger than 25, but I've also filtered for weight needs to be smaller than 2. You see, so here I had 6 in total because some of the weights were bigger than 2, but this row and this row, I've lost it. But now I do this, as the first operation, and you see this is now a data set. It's now a data set, but now if I select this data set for certain columns, well, I'm going to keep only the columns that I want. Now, okay, if you have many operations like that, select, filter, and then other things, maybe the notation is going to actually get a bit cumbersome. And we actually said before that dplyr helps you to avoid cumbersome notation. So we do need this so-called pipeline operator. I mean, I don't know if we need it, but it definitely makes our life easier. So within dplyr, you have this useful operator. Careful with the syntax, percentage sign, then I suppose bigger or arrow. I don't know what to call this, and then percentage sign again. And this you call it pipe. Okay, so A pipe B, for example. Now, how to think of this operator? What it does? Think of it as a and then. So and then. So do something, then pipe, do something else. Okay, so do something and then do something else. That should become clear with the following example. So now we're going to do something we could already do, but we're going to use the pipeline operator. So empty cars. So here I'm just naming my data set or data frame. So empty cars and then filter. But you see, the use of filter we had before was slightly different because we needed to name the data set inside filter. But if you use the pipeline operator, R already knows that you're using the data set because you say, okay, grab this data set and then filter it by MPG bigger than 5 and weight smaller than 2. So you see this as the correct or expected outcome. I've grabbed my data set, but now I've filtered it as before. I've just kept the 4 rows where MPG is bigger than 25 and weight is smaller than 2. But this one is not especially useful. Where it gets useful is when you have many operations one after the other. For example, again, grab my empty cars and then filter for MPG bigger than 25, weight smaller than 2. But then I'm not done. And then I want to do something else. So, and then select the columns that I want. So you see, this code, empty cars, filter, and then select, does exactly the same thing as the one I had before. But I don't know if you agree, this looks a bit nicer because you kind of read line by line, do this, and then do this, and then do this. This one, okay, it's understandable. You take a couple seconds, I think you can understand what this does, but because you have something inside a bracket, like a bracket inside a bracket, it takes a bit longer to understand what's going on. And this is still a relatively simple one. So if you have many different operations, definitely the pipeline is way neater and much easier to understand what the code is doing. Okay, so now we've covered filter and select. We've covered the pipeline operator. There's another function to cover. I mean, there's a few more. So arrange. Arrange is relatively simple. You can sort your data frame according to the value of a specific variable. So let's look at an example. Empty cars, and then I'm going to filter. So I'm just going to keep the rows where MPG is bigger than 25. And then I'm going to arrange my data set in ascending order of weight. So you see, that's my data set as before, like the 6 cars that have MPG bigger than 25, but now they are in ascending order of weight. Okay, so the smaller weight is first and so on. The bigger weight is the last row. If you want descending order, you just need the trick that you use this, descending of weight. So I'm arranging, but I want in descending order of weight, which in case, of course, I'm going to get weight, the bigger weight first, and the second bigger, and so on. Okay, relatively simple. That is the arrange function. Now we get to mutate. So that's the next function to cover in dplyr, the fourth one. Remember, we have 6. So mutate easily allows you to create new variables. So very common that you have a data set, you're doing some statistical analysis, you want to create a new variable based on existing variables. Very easy to do that with mutate. Just a few simple examples here. Always now I use my pipeline operator, so empty cars, and then mutate. So mutate brackets, what I put inside mutate is the names of my new variables I'm creating. So I'm creating new variables, obviously very exciting. So their names and then what they are. What they are as a function of the existing variables. So here, some simple examples. For some reason, we're creating a variable called double weight, where it's just twice the weight. Maybe we missed the opportunity here to create a variable that is the weight in kilograms, right? Which would be 2 times 2.2 or something. But anyway, now we just create a variable that's twice the weight. We want kilometers per gallon instead of miles per gallon. So obviously we just need to multiply miles per gallon by whatever constant we need. You know, how many kilometers there are in 1 mile, roughly 1.61. And then the last one, okay, well here, frankly, it's not especially useful, but we create a variable like a new column that is the name of the cars. Now, maybe this is slightly confusing because now we have the names twice. Rows can have names in data sets, right? In data frames. It's not mandatory at all. It's a feature of the data frame structure in R. A row can have a name that is not a specific variable in the data frame. So you see, this data frame, as was displayed before, add rows for each, as name for each rows, right? So you know that this row corresponds to the Honda Civic, right? But Honda Civic is not a variable in the data frame. It's just the name of the row. But now for some reason, if you want to create a variable in the data set here called name that has the names of your cars, you can do that by creating name here using function mutate. And you grab, so row names is a command in R. So row names of empty cars, row names will then contain these things that I replicate here. But again, I'm not saying it's especially useful, but I suppose it's just another example of creating a variable. And then lastly, once I've created my variables here, I want to select just a few for display here. So select blah, blah, blah. And that is mutate. So I suppose we have 2 more functions to cover, but first, one more note on the pipeline operator. So why do we use the pipeline operator? I don't know if you're convinced yet, but it makes it much easier to read what is going on. This is just another example, but the following 2 pieces of code achieve the same thing. So here, this one without the pipeline is just a bit harder to read. Now you can certainly read it and understand it, but it takes a bit of time to understand, okay, what's in the first, like, inner bracket is the first thing that's done. So this is the first thing. I'm filtering for again, the cars that have MPG bigger than 25. And once this is done, I'm going to select whatever the result of the filtering is, but select for the MPG weight and cylinder. Okay, so that's the second thing I've done. And then the last one, arrange. So I'm going to arrange everything by order of descending weight. Okay, you can understand it, but it's a little bit maybe cumbersome. Compare this to the pipeline, then I think it's neater. I just one thing after the other, and it's very clear what I'm doing. Grab my empty car and then filter for MPG and then select what I like and then arrange based on whatever criteria. You see, I think it's fair to say it's easier, which is what is written there. Well, you need some concentration to understand the first bit of code. In contrast, the other one is easy to interpret. Okay, and this is just what I've explained verbally to you. Okay, so now we get to the exciting functions summarize and group by. So let's start with summarize. Summarize gives you a summary statistic. So for example, I get my empty car and then I will summarize in the following fashion. Now careful, I'm naming the things, the summary statistics I want to grab, but this part, those are not like keywords. I can name them whatever I want. So here I'm naming a summary statistic to be the mean of MPG. What is it equal to? Well, the mean of MPG. So careful, that's a name. That's a function. That's a function of my MPG variable. And by the way, maybe I should have mentioned here, we don't have dollar signs, right? We don't need dollar signs because R knows straight away we're using empty cars, right? So within empty cars, there's a variable called MPG. I grab it straight away. I don't need those ugly dollar signs. Okay, the other one is just the number of observations in this data set. So number of cars, there's just a function called n. I don't need any argument because this is just counting the number of rows in the data set. So I don't need any argument here. And then lastly, I'm interested in the standard deviation of weight, and I grab that. Okay, and this is the result. So again, I've created the variable now, or called mean MPG, number of cards 32, and standard dev. So that's summarize. Like it's moderately useful, but frankly, we could have done this with base R relatively easily. What is quite powerful is group by, and then you use summarize. So let's explain that. Here they tell you it's a powerful function that will group rows into different categories, and then you use summarize to find summary statistics of each group. Okay, that sounds confusing, so let's present the example. Again, I have my cars. I'm grouping them by their cylinder. This means that I'm going to find all the cars that have a specific value for cylinder, and then all the cars that have another value for cylinder, and so on. And within those groups, then I can find summary statistics. So for example, I will then summarize finding the mean of MPG, but again, this is then within my subgroups. So then the result is this. I get the average MPG, so the mean of MPG, but for all the cars that have cylinder equal to 4. So careful here how to interpret this table, which is the result of those commands. For all the cars that have a cylinder equal to 4, the average MPG is this. For all the cars that have a cylinder equal to 6, average MPG is this, and so on. You see, by here, apparently there's only 3 possible cylinder, so then you get the average. And okay, this is a small example, but in general, it's very powerful to be able to do that because often in statistical analysis, you have subgroups of the population and you want to find interesting statistics about each subgroup, right? Average income by education level, things like that, right? So here in this case, average mile per hour for different cylinders. And well, I know nothing about cars to be honest, but I guess the bigger the cylinder, the more powerful the car is. And then, well, the car can do less miles per gallon, which I suppose makes sense. Okay, some summary statistics, we've presented them already. Now as a comment, group by, you can use it on multiple features. So you can create groups on which you want to find interesting statistics by many variables at a time. So for example, if I group by both cylinder and gear, for example, then I can find any statistics. Okay, so the effect of grabbing my data set and then grouping by those 2 variables and then finding the summary statistics. Here, for some reason, I want the median horsepower. What will be this? A table that, well, now my groups are based on two different variables, right? So for the group of cars that have cylinder equal to 4, gear equals to 3, so all the cars that satisfy this, the median horsepower is 97. For all the cars that have cylinder 4, gear 4, the median horsepower is 66, and so on. Now, there's only 32 cars in this data set, so I'm guessing some of those values might be based on only one or two observations. I don't know, I would need to check. But this is what you obtain. Statistics for subgroups of your population. And by the way, it looks like, okay, no car, careful here. Apparently no car has cylinder of 8 and a gear of 4. So you see the category 8 and 4 that doesn't exist. Apparently no car has this combination of cylinder and gear. Okay, I've been talking a lot, so maybe you can try this relatively simple exercise for yourself. We're going to use a different data set, quakes, which is part of base R. Find all the rows with magnitude greater or equal to 5.5, and then display only the columns depth, mag, and stations. Hopefully you see that this should be an application of filter and select. So try to do it. Now I present a solution. So obviously filter because I want the rows with this variable bigger than 5.5, and then I select whatever was here. Okay, another example. Hopefully this one should use the other functions. So okay, this one is again, we're back to empty cars. Create a new variable which is the product of MPG times WT. So yeah, this should test your understanding of mutate, creating a new variable. And then once you've done that, find the mean, median of this new variable, but within each possible value of sil. And then do you notice something? But now, if you want the mean, median within each possible value of sil, this should be an application of the function group by and then summarize. Yes, correct. So let's look at the solution. I'm grabbing my data set, mutate, I'm creating my new variable. Here again, I name this whatever I like, MPG times WT for weight. And then I didn't say it, hopefully it's clear enough that here, of course, those are like the multiplication of two vectors, but like row by row, right? Of course, so for the first row in the data set, the MPG is multiplied by the weight, and so obviously this computes an operation for every row of the data set. But I'm pretty sure you figured this out already. And then whatever group by, so I'm grouping by cylinder because again I want some statistics about all the observations that correspond to a given cylinder. So I found the mean and the median. And then they ask you, do you not notice something? Well, look at those numbers. I think what this question is going after is simply those numbers, they don't change too much, right? They don't change too much, which when you think about it, makes some sense that they're pretty stable because if the weight of a car increases, then most likely the miles per gallon will decrease, right? Bigger cars, they do fewer miles per gallon. So the multiplication is relatively constant, right? For different subgroups, the multiplication is the same because again, cars that tend to have a high weight will have a lower this, or if miles per gallon is higher, well, the weight will tend to be lower. So the multiplication of those two things, taken as an average for everybody with given cylinders, relatively stable. Okay, I don't know if you're convinced that dplyr is neat and useful, but now we present a few more examples. So why use dplyr? Well, generally easier to read and write than in base R. And here, I don't think I'm going to spend too much time on those examples. They're just examples of, okay, you could do those things in base R. You could do them, but often it's more complicated. Now, the first example is relatively basic. So in dplyr, again, the kind of stuff we've been talking about for the last 20 minutes or no, more like 30 minutes. I don't know when I started the video, but anyway, I'm creating a new variable. I'm creating name. I'm creating here kilometers I suppose that, yeah, kilometers per liter. Okay, so if I want everything in metric, so kilometers per liter would be this. And then again, I'm filtering, so I keep some certain rows and then I select some certain columns. You can do that in base R. This one is not too bad in base R, I suppose, because base R is kind of okay to select rows and select columns. So for example here, empty cars, if I grab the MPG that is bigger than 25 and the weight that is smaller or equal to 2, that should work. I select all the rows that satisfy this, and then I select all the columns, which selecting all the columns of a data frame, you can have comma, and then you don't put anything. So this, as we've seen before, we select all the columns. You can create a new variable in R with the syntax. So, okay, so here I've created my new data frame. This is just a name for my new data frame. So new data frame, I'm creating a new variable that I'm going to call here KMPL, kilometers per liters. I assign to it whatever I want. And this works. I'm grabbing my miles per gallon. Here, I do need the $sign and then multiply by those constants. That's fine. And then if I want to select specific columns, I can do that. I select all the rows, because I don't put anything here. I just put the comma, and then I specifically name the columns that I want. Okay, that's fine. But I do feel this is already a bit more elegant and followable, if that's a word. But now if we get to more examples, we'll see the stuff you can do with group by and summarize is quite hard to do with base R. You can do it, but frankly, in this example, I just group by my cylinder and my gear, and then I find the summary statistic within groups. Doing this in base R, I'm not even going to review this code. It's quite complicated. I kind of discourage you to attempt to do those things in base R when you have this nice, elegant dplyr there for you to utilize. One more example of stuff you can do pretty easily in dplyr. Count the number of observations within given intervals. Yeah, that's the kind of stuff that you might encounter this kind of task. So here, I suppose, for some reason, we're back to the sample data example. So this was the sample of people having different diets. I want to count all the people that are within different intervals for a specific value. For some reason here in this example, we use height. So we want to count how many people are between 140 and 150 centimeter, 150 and 160, and so on. Now, here, I need to explain, you need this function cut. So that's a new function we would not have seen before. So mutate, here I'm creating a variable that will be categorical, that will simply tell me the category based on a numerical variable, but now transform to an interval. Like, is the person between 140 and 150 or between 150 and 160 and so on? This, I need a function cut to do that, but the syntax is cut the numerical variable I need, and then the breaks I need. And write f, I believe, would mean is the right interval closed or open, right? So basically, somebody who's on the boundary that is exactly 150 centimeters, well, they will count in the next category. They will count from the category 150 to 160 because the right bound is open in this case, is open. I don't know if that makes sense. Maybe I can show you this in R just to make it slightly clearer. I'll go back to my RStudio here. Now my sample data is already there. So well, let's just download and attach it again. If I do this, you see for every value of height, now I obtain something that looks categorical, right? Or this one is between 150 and 160 and so on. But that was just one part of the code. Now I'm creating intervals. So I'm creating intervals. I'm creating a variable called ints equal to that. But then I can group by, and basically, if I group by ints, I can find the number of people. So the number of people in this interval of height is 3. 70 people are between 150 and 160, and so on. Okay, not too complicated if you know how cut works. To do that in base R, again, I think it's complicated enough that it's not even worth it for me to review it because my recommendation in real life would be to use dplyr to do something like this. If you want to spend some time understanding this code, be my guest. It does work, right? It does produce the same numbers here, apparently. Okay, that's more or less the end of dplyr. Here, there's just a bit more information. This is an introduction to dplyr. There's other kind of cool stuff you can do. Here, there's a link to a cheat sheet, like a summary of all the functions. Some online tutorials. So there's actually a website dedicated to dplyr. There's also this textbook. So R for data science is a very, very popular reference about well, R for data science. So I would say in your R learning journey, almost certainly you'll encounter this textbook, which is popular and useful resource that heavily uses. So it's a recent textbook, so it heavily uses dplyr and the tidyverse in general. And then there's one more note. You may have noticed, if you're observant, that in fact dplyr doesn't return a data frame. dplyr returns something called a tibble, and here, there's a link here you could click to get more information about tibbles. For example, slide 25. Let's go back just to give the example. I don't know how you can tell that this is a tibble. So maybe I think you can tell when you go to RStudio, right? Let me just copy this code. Okay, something didn't work here. I'm not entirely sure what. Obviously I made the mistake on purpose so that we all learn together. I did not load my package, right? So I need to, again, I make all sorts of silly mistakes myself. I'm not perfect. Obviously I can make mistakes. So dplyr, then after that it should work. And again, but this maybe is pedagogical, right? To use the function inside dplyr, obviously I need to load dplyr into my R session, then this should work. And interestingly, this looks to me as a data set. So let me name it. Here I'm I suppose learning on the fly. So I'm named this df. Now, what is the class of df? It's a data frame. So it is indeed a data frame. I think because empty cars is a data frame, so it's not going to convert it to a tibble. So sorry about that. I'm not entirely sure how I can get a tibble to show you what a tibble looks like, but in essence here, the comment is just that when you use dplyr, often you get a tibble, not a data frame. But this is just a side note to say, don't stress about tibbles. Tables are basically a more modern version of a data frame designed to work better. And so they work in the same way as data frames. There are some differences. So if you want to read, again, this is a link you can click. You can learn about the maybe slightly subtle difference between the tibble and the data frame. But for our purposes, it's fine. Like whether it's a tibble or a data frame, we'll be able to work with it. So I don't think it's going to be an issue for us. And again, sorry if I sound slightly confused here. This one. Okay, sorry about that. I think there was a wrong reference because slide 25 doesn't look like it has a tibble, but okay, it looks like when you summarize, then you get a tibble. So this is what I meant. A tibble. So maybe you would be confused, but just view this as almost equivalent to a data frame, but it has some subtle differences that for us are not gonna matter too much. Okay, but this is the explanation of this word, a tibble. But it's also, a table, right? Rows, columns, like a data frame. Okay, again, apologies for the slight confusion at the end, but we've made it. That's the end of the video. Now you have some homework to do. So I'll leave you to it and see you hopefully in class or in the next video.